Welcome back. So we're looking at this diagram. So circle A represents some integer solutions where x is less than 0. And if you see -4, -78, -1, -17, they're all less than 0. And then we have circle B over here that represents some integer solutions that are greater than 10, like 12, 15, 25, and 400. So if we're going to combine these, the combined and the solutions could either be in this circle, circle A, or they could be in circle B. This would be a type of compound inequality, which is referred to as an OR. So the solution can be in circle A, or it can be in circle B. Or you can say x is less than 0, or x is greater than 10. So anything in these regions would be solutions, and anything that did not fall in those regions would not be solutions. So something like 1, right? 1 isn't less than 0, and it's not greater than 10. So that wouldn't be a solution, or 3 wouldn't be a solution either. So none of those would be solutions. But -4 is less than 0, so that would be a solution, or 12 is greater than 10. So anything that falls in between these, it can be in circle A or circle B, those can be the solutions. And you can graph the solutions of a compound inequality involving OR, that's the key word, by using the idea of combining the regions. So basically you have x is less than 0, right here's 0, right? And so we're going to use that. There's x is less than 0, and then you have x is greater than 0. That was at circle B here. And with the these combined regions, when you combine these together and write them as one thing, it's called a union. It's a union of both of these inequalities. So the combined regions are called the union and show the numbers that are solutions of either inequality. So you would write this as x is less than 0 or x is greater than 10. And you have to write this. This is a must. A must for your quiz, a must for your homework, a must for your test. You have to have that, or else it will be wrong. All right? So let's go ahead and look at a few examples. So the first example here, I just love these. And the reason why is, at first when I learned these, I'm like, oh my gosh, this looks so complicated with the ands and the ors. I'm like, I've never seen anything like this. But the thing about it is, basically, if you just cover this up and you do that one inequality, it becomes really, really super easy. And then when you get done with that, you cover that one up and you just do that. You just do it separately. I mean, that's basically it. So we got to figure out what t is. So we're just going to subtract 8 to both sides, right? So we end up with t is greater than or equal to 7 minus 8 is -1, or, and then you do the same thing over here, right? We want to get t by itself, so we subtract 8 again, and we end up with t is less than 2 minus 8 is -6. Now the only thing you have to do is you have to make sure the smaller one, like here, when we had x is less than 0, those are representing the smaller solutions, right? And this x is greater than 10 is representing the bigger solutions. And it really just has that pattern of the OR, right? This is what the shape of the OR is. It could be something like this. But basically is you have two circles and then they go in opposite directions like that, leaving a hole in the middle. That's what an OR looks like. Okay, it can be this or that, all right? So for here, we want to make sure we have the smaller solutions written on the left side. And that would be this right here, t being less than -6, or t is greater than or equal to -1. We just swap them. We don't change anything. We just swap the order so that the smaller one is written on the left and the bigger one is written on the right. So make sure you do that on your homework, quizzes, and tests as well. And then we just graph it, right? So we're going to have a, that's going to be an open circle, and t is less than, right? And then t is greater than -1. -1 is here. That's going to be a closed circle. This is -1. And t is greater than, so it's all those solutions. And it has that or shape, which is perfect. So yeah, that's how you do it. You write your solution, the smaller one here that represents these smaller solutions, and the bigger one here that represents the bigger solutions. Okay, let's look at the next example. Example 3b. We're gonna go ahead and solve for x. So really just think about it like this, right? Cover it up and just solve that one, and then cover that one up and just solve that. It becomes super, super easy. So we're just gonna divide both sides by 4. And boom, there we have it. And then we divide both sides by 3. Like, you should seriously just, you know, breeze through this. But if you have problems or issues, let me know and I can help you. So maybe I just, if didn't explain something very well, if you're having a hard time. I know that, I mean, you just have to, like, it's new, it's different. It kind of, you know, when you first get it, like the ands, the ors, like what's going on. But it basically, like, 2 inequalities, you just write them as one. You kind of, it's like a condensed version. And sometimes there's a lot of different applications where it can be in either of these requirements. So, I mean, we looked at some of the examples in example 1 where it was talking about the pH level, right? Like, the pH is good if it's in between these levels, or the chlorine in the pool is good if it's in those two. And those are both and examples of applications. So, all right, so let's go ahead and graph this. So, oh, do we have the smaller one? Yeah, we do. Okay, so this is where 5 is. This is where 7 is. Halfway between 4 and 6. At 5, it's going to be a closed circle. Answers go this way. At 7, what is it? A closed or an open circle? Open, open, open. And then x is greater than, it has that or shape, and boom shakalaka, there we have it. All right, now it is your turn, ladies and gentlemen, to check it out. I want to see how you can do 3A and 3B. I want you to go ahead and knock these problems out, solve them, graph them. Oh, and press pause, work them out. When you get done, press play, and we'll go over them. All right, see you in a bit. All right, let's see how you did. So we are just going to take one of these inequalities at a time, solve this one, then solve that one. All right? So we're going to subtract 2 to both sides. We got r is less than 10, or we subtract 5 to both sides. R is greater than 14. Smaller one, bigger one, perfect. Time to box it. That is our solution set. And now we graph. So where's 10? 10 is halfway between 8 and 12. And that's going to be an open circle. Open, open. And r is less than. And then 14 is halfway between 12 and 16. That's going to also be an open circle. Perfect, perfect. So if you got this right and you graphed it correctly, woohoo, you're doing amazing. On to the next one. Check it out, 3B. Let's see how you did. So we're going to solve this one and then solve that one separately. So we're just going to divide by 7 to both sides. X is greater than or equal to 3. Or divide by 2 to both sides, and we have x is less than -1. So is this the smaller one, or is this a smaller one? This is definitely the smaller one. So we have to make sure that we wrote that. So hopefully you did. If not, go ahead and adjust that on your paper now. This is the bigger one, so that one goes on the right. And then we have smaller, bigger, boom, time to box it. And then we just graph this bad boy. So we go to -1, open circle, x is less than, boom, that way. Go to 3, it's a closed circle, and x is greater than or equal to 3, and boom, that way. There you have it. If you did both of these right, awesome, awesome. Yokanenki Masha, you're doing a wonderful job, and I'll see you in a little bit for example 4.